Okay, so I am going to review some of the exponents and what happens when a number is raised to a power of 0, or what happens when a number is raised to a negative power. So let's just look, for example, 3. We have 3 to the power of 4. If we expand it, this is called expanded form. We have the base multiplied by itself 4 times. So 3 times 3 times 3 times 3 is 81. Then 3 to the power of 3 will be 3 times 3 times 3, which is 27. 3 to the power of 2 is 3 times 3, which is 9. And 3 to the power of, let's see what happened here. 3 to the first power, we know that invisible 1, this is a power 1. We don't need to write it. It's just 3. And if you look at these exponents, we are going down by 1, 4, 3, 2, 1. So that means the next one should be 0. So how can we write these numbers without changing anything? Right here, look. All this. You can multiply by 1, right? Nothing changes. Nothing changes. So here, there is a 1. An invisible 1. Or if you don't understand it like that, you could see that from 81 we go to 27 if we divide 81 by 3. If you divide 27 by 3, you will get to 9. If you divide 9 by 3, you get 3. And if you divide 3 by 3, you will get 1. So that tells you any number to the 0 power is always 1. I'm going to do the same thing right here on the side, but instead of using the base 3, I'm going to use the base 2. So 2 to the power of 4, we write it in expanded form. 2 times 2 times 2 times 2 is 16. Then 2 to the power of 3, the base is 2, and the exponent tells me multiply that 3 times. That's 8. 2 times 2 is 4. 4 times 2 is 8. 2 to the second power is 2 times 2, which is 4. 2 to the first power, now we know what the power 1 is invisible, but I'm going to write it here just so you guys see it. That's 2. And 2 to the 0 power. We can use the same thing that we did before with the 3. How do I get from 16 to 8? I divide it by 2. How do you get from 8 to 4? Divided by 2. How do we get from 4 to 2? Divided by 2. And one more time, 2 divided by 2 is 1. So as you can see again, 2 to the 0 power is 1. So we can just say that, I'm going to put it here on the top, any number to the 0 power equals 1. So any number to the 0 power always equals to 1. All right, let's highlight that. Okay, so it doesn't matter what number they give you. If it's raised to the power of 0, it is always 1, even if it's a negative, okay? Now, we're going to go down and we are going to talk about negatives. Because as you can see, if we keep on going down here, 1, 0, see we're going 4, 3, 2, 1, 0. The next ones will be the negatives, right? So I'm going to do the negative. So 3 to the negative 1. Well, 3 to the negative 1, if you look at this right here, and you keep going in the pattern, you're going to have to divide by 3. So the next one will be 1 divided by 3 is 1 over 3. It's 1/3. If you do the next one, 3 to the negative 2, if you divide this by 3, 1/3 divided by 3rd is 1/9. And hopefully you notice that this right here to the negative 1 is kind of the same thing as the positive 1. 3 to the first is 3, but 3 to the negative 1 is 1/3. So it's the same thing but reciprocal. So you flip it over. 3 to the negative 2 is related to 3 to the positive 2. Here the answer is 9. So therefore here I would write it as a fraction and it will be 3 to the negative 2 is 1/9. Okay, same thing for the 2's. 2 to the negative 1, it will be half of 1, which is 1/2. You can see it's a reciprocal of 2 to the power of 1. 2 to the power of negative 2. Well, if 2 to the power of 2 is 4, then this should be 1/4. And it is, because if you cut this in half, 1/2 divided by 2 is 1/4. So when you have negative powers, let's say you have 3 to the negative 3, we would have to switch. If it's on the top, we will put it on the bottom and it will become 3 to the third. So it does become a fraction. It will be 1, 3 times 3 times 3. It will be 1/27, 1/27. 3 to the positive 3 is 27. Therefore, 3 to the negative 3 is 1/27. Hopefully you can see the relationship.